In this lesson, we will be introducing the unit circle. Let's revisit our lessons on sine, cosine, and tangent. We used an archery example to derive these functions. In this example, we created an arc using the values of sine and cosine from 0 to 90 degrees. At an angle of 0, we have a cosine of 1 and a sine of 0. As we increase our angle, the cosine decreases and the sine increases until we hit 90 degrees, where we have a cosine of 0 and a sine of 1. You may have noticed that these appear to be coordinates. If we place this arc on a coordinate plane, we can see that our values of cosine are the x-coordinate and our values of sine are the y-coordinate. What we didn't mention before is that the arc we created is actually a quarter of a circle, which we call the unit circle. The unit circle is simply a circle with a radius of 1. We learn the unit circle because it gives us easy access to the sines and cosines and consequently the tangents of any of the angles between 0 and 360 degrees. We also get a useful identity from its equation. So let's derive this equation. If you'll recall from our videos on sine, cosine, and tangent, we used triangles to calculate the trig values. And we know we can get the lengths of the sides of a triangle using the Pythagorean theorem. As we said before, the unit circle has a radius of 1, so any triangle we could create has a hypotenuse of 1. We can rewrite the Pythagorean theorem to reflect this. We also are referring to a coordinate system with our graph. So instead of using the variables a and b, it would make more sense to use x and y. So again, we rewrite our equation, and this is the equation of the unit circle. We know our value of x is also the cosine, and our value of y is also the sine. So we can substitute our trig functions for these variables. And this is the identity we set out to derive. This identity is used constantly in calculus, so this is an important one to memorize. We said that we use the unit circle to have easy access to the sines and cosines of any angle between 0 and 360 degrees. The angles that are most important and will come up the most often are 0, 30, 45, 60, and 90 degrees. Luckily, we've derived all of these values in previous videos, so those are filled in here. Each quadrant of the unit circle has points that correspond to those in the first quadrant, and we call these reference angles. This is best described with visuals. We can see that in the second quadrant, the x values are negated and the y values are still positive. So we need to take this into account for our sines and cosines. In the third quadrant, both the x and y values are negative. And finally, in the fourth quadrant, the x value is still positive, but the y value is negated. We have created this reference sheet, which is available on our website for you to use to easily access all of these values. Tangents are also included on this sheet, even though we didn't talk much about those values in this lesson specifically. We've already done a few lessons with examples on how to calculate sine and cosine, so instead of reiterating that here, we're just going to direct you to our sine and cosine, tangent, and special triangles lessons if you need extra practice with that. We hope you found this lesson to be helpful, and if you did, make sure you like this video and subscribe to stay up to date on our content.